More and more children are out of school, but parents don't want math learning to stop. They're turning to Mathnasium at Home, real-time math instruction tailored to your child's exact educational needs. It's the same face-to-face live instruction used in our centers for over 15 years, now on a computer. Your child can keep their math skills sharp, catch up, or soar ahead, from home or anywhere with an internet connection. To learn if Mathnasium at Home is right for your child, visit mathnasium.com/at-home. Mathnasium at Home, changing lives through math.
Hello everyone, welcome back to Mathnasium Schoolhouse. My name is Sandra and I will be your instructor for today as we explore our first of our 2-day series on solving proportions. For those of you that have maybe followed us on maybe even every time we do our Schoolhouse lessons, I touched on proportions the slightest bit when I had my Math and Art series. And we looked at scale factors, and we of course had to look at proportions through there. But the only thing that we didn't do there was actually go in depth into how we would solve proportions. We just kind of did it. And so I figured, you know what, a great Schoolhouse lesson as a follow-up to that, or maybe even in preparation for those of you that want to then look at that application, would be to focus on solving proportions. The beautiful thing about proportions, which we'll explore in just a second on my whiteboard, is that, sorry, I just wanted to make sure I'm not muted. All good. Is that there are variations of them that we could encounter. And so because of that, I've decided to divide maybe them into 2 different groups. We'll explore one group today. We'll look at a specific technique used in solving certain proportions, and when that's not useful, we'll look at what we can do with those problems tomorrow. So let's get started. I continue to say hello for those of us that are joining us today. And I say this every time, but I'm interested to hear which level you're at. This might be most appropriate for those of you that are maybe going into middle school as of September. But who knows, maybe some of you are ready for this well in advance, or maybe you're in high school and you maybe found proportions challenging. You'll definitely encounter proportions in algebra classes and beyond, and so this might be a good review for you. So let's go into my whiteboard. As always, I will be using the follow along document that was shared on our Facebook page a few hours ago. If you want to pull that up as I just do a brief introduction on my whiteboard here, you can do that. I will have that PDF shared through my screen as well, but you're more than welcome to have it as open as well. It does have practice problems at the end on top of what we'll do together. And for those of you that might be new to these Schoolhouse lessons, typically the structure we follow here is we'll do some problems together to really practice and reinforce these lessons that we're addressing for the day. And if you'd like more, you are welcome to reach out to your nearest Mathnasium. Maybe you are already a student, which is perfect. I'd love to know that. If you are, please share that in the comments. If you do join us at Mathnasium, our approach there will be to really assess where you are with your math skills and then build a learning plan that's specific to you, customized to you. And so when it comes to something like solving proportions, we'll really get to see if you're ready for that, or maybe you'd benefit from more practice, more applications, and so on. So I welcome you to reach out to Mathnasium Center near you, but not until this lesson is done, so that you can join me today and help me out in answering some of these questions. So enough about that. Let's look at proportions. And let me just refresh. Looks like I'm not getting too many comments here. While I refresh my screen, I'd love to see and hear and read, I should say, from you guys, what is a proportion? What do you understand proportions to be? So go ahead and share that with me. There we go. Now I'm seeing some more. There we go. Perfect. Sometimes a refresh is exactly what you need to do. So what is a proportion? What do we understand them to be? I'm seeing 7th grade here. Beautiful. There we go. That's what I like to see. Participation from you guys. So proportions, let me pull out maybe a different color here. You'll see them as fractions or ratios that we compare. And rather than me writing out the definition, let me just state it. It is a statement itself. And so we'll look at solving proportions, but also applying them to word problems. If you've already looked at that document, there are some there. But a proportion is a statement that involves two ratios. Like I said, we might represent those as fractions most of the time. For the purpose of today, we will. That are equal. So two ratios, fractions that are equal, and typically within those proportions and those proportion problems, we are solving for some unknown. And that's where, if you are in middle school, this is most appropriate for you because you've already explored those steps leading up to solving equations or anything along those lines. So it's where, like I said, we're having two fractions equal to one another. So for example, if I gave you a problem and I said, this weekend, when the weekend rolls around, I want to make pies, and I know that 3 pies, this is just an example, it's not on your worksheet just yet. 3 pies can be made from 15 peaches. We're making peach pies. Okay? I know this information. Maybe I have a recipe passed down from my grandma or something like that, and it is telling me that I can make with that recipe 3 pies and that I need 15 peaches altogether. Great, I have that piece of information, but I want to make 7 pies, all right? So I need to know how many peaches do I need to go buy from the farmer's market, let's say. I want to bake 7 pies. So the question is, how many peaches will I need? So this is exactly where proportions really help us out in figuring out missing pieces of information. Okay, so I'm not seeing your comments here. I'm gonna have to refresh one more time. While I do that, how about you guys maybe start to tell me, how would I find out how many peaches I would need? And specifically, how can I form a proportion from this information to solve for that? Okay. Of course, you might decide to create a visual if that's helpful to you, or some of you might jump to some algebraic statement that you can then solve for the unknown variable in. Okay. So as I said, you could create, oh, beautiful. So now that I've refreshed, I see some beautiful comments here already. I'm seeing 5 peaches in 1 pie, so that's definitely what you can do here. So I purposefully chose these numbers because we could, in fact, reduce it, and we'll review that as well. Today's focus in solving proportions will be with reducing fractions, looking at equivalent fractions, which is probably what you guys are discussing there. So when I have 3 peaches, I might decide to visualize this in my mind, and I don't want to focus on the visuals too much today. I want to jump into the algebra. But yes, I can visualize in my mind 3 pies, 15 peaches. That means each pie uses 5 peaches. And so if I actually want 7 pies, I need 3 plus 1 more. So knowing that each pie has 5 peaches, I can sum that up and get it. So let's not get that answer just yet. Some of you might already know it, and I'm already seeing it actually in the comments. Beautiful. But what if I wanted to set up that proportion? What could I do? Well, I could compare the same amounts. So what I could do here is say 3 pies use 15 peaches. And that has to be that same proportion, that same relationship, that same ratio. Different ways we can explain that. Has to hold for this, right? So think back to my recipe. I don't want to add too many peaches or too little peaches. I want that same amount. I want the pies to taste the same way, have the same amount of peaches in there. So if I want 7 pies, now I have an unknown amount. So you might want a question mark there. You might choose to have a variable. Our favorite variable in math is x. Whatever you decide to do, you could have a capital P for peaches. You want to solve for that x. And so that's what we will be looking at today. Some of you jumped steps ahead and told me, well, I can reduce 3 over 15 or 3/15 to be 1/5, and then use that information to find how many peaches. So again, my comments are not refreshing, so rather than spend the time refreshing that, let me pose you with some problems, and the problems will be specifically looking at reducing fractions and providing for me equivalent fractions. Because once we've mastered that, we are more than ready for today's proportions on our follow-along worksheet. So let's spend just a few minutes doing that, just to make sure we're all on the same page here. So let me pose some here for you. Could you please provide for me an equivalent fraction for 2/3 where my denominator is 15? So what should be in this box here? And then what if I gave you 6/7 with a numerator of 18 in my equivalent fraction? And then what if I asked you for 5 over some number is equal to 40/64? And then one last one, a box in the numerator, a 5 in the denominator, and that is equal to 27/45. So I will refresh my comments. I really want to have you guys participate and acknowledge some of those. And I'll fill in those boxes as I see them on my screen. So let's see what you guys have here. Again, this is the prerequisite skill we would need to really master today's proportions. So what do we have here? I'm seeing a bunch of 10s. I'm going to assume that is for the first one. Why is that true? For those of you that maybe don't understand why some of those comments are showing 10, if we're looking at equivalent fractions, how do I get from a denominator of 3 to a denominator of 5? I multiply by 5. Sorry, did I say 5? This is 15. I multiply by 5. What I do to the denominator, I must do to the numerator because we're speaking of equivalent fractions, which is a different lesson, but I just want to review this here, which is why we received a 10, because 2 times 5 is 10. I'm seeing a 21 somewhere, and that is for the second question. And just really briefly, 6 multiplied by 3 does give me 18. Since I had those two numerators, I can relate them, or a better way to put it is, what's the best way? Describe that relationship. So this is 3 times this numerator. So what I do to the top, I must do to the bottom. I'm going to refresh my screen to see hopefully the answers to the last 2 problems. Would love to see what you guys got. And hopefully it is in fact an 8 here. Yeah, I'm seeing an 8 here, perfect. Because 5 multiplied by 8 gives me the 40. Something multiplied by 8 gives me 64. I know my multiplication facts, 8 times 8 is 64. And I can think of it the same way here. These are the 2 pieces of information I have, the 2 denominators. The relationship between them is that 5 multiplied by 9 is 45. All right. And so what I do to the bottom, I must do to the top. So something multiplied by 9 gives me 27, and that something is in fact, I'll just use my green, is in fact 3. Okay. So notice I purposefully chose these ones because we were looking for the numbers in different spots. Numerator for the second fraction, denominator for the second, denominator for the first, numerator for the first. Just so you guys can see, we're using the same thinking. We're trying to explore the relationship between the 2 knowns and then use that same relationship for the unknown that we're looking for. Perfect. And if I just remove that and ask you really quickly, maybe 2 questions here, how about you guys reduce these 2 for me? Because in solving proportions, another great skill to have in our back pocket is the ability to reduce fractions. So let me just double check that you guys are on the same page here with me. If I have 55/88, what does that reduce to? And 26/34. And then we'll move on here. And I will refresh my screen one more time. Give you some time to work those out. So what do we get here? Well, how do we reduce fractions? Again, a separate lesson that we might explore in our schoolhouse. But I'm seeing 5/8 here. That's wonderful. So we reduce it by the greatest number that you can think of it as fits in or divides evenly into both the numerator and the denominator. And that, of course, hopefully it's very apparent to you, is 11. 55 divided by 11 is 5. 88 divided by 11 is 8. Beautiful. And what can I do with the 26/34? How can I reduce that? If I can't think of that greatest common factor automatically, I can start to divide by 2 and see if I can keep on going with that pattern. Regardless, I get here, and I actually want to double check what you guys are saying. Perfect. I'm seeing 13/17 from Rekha. Beautiful. Yeah, if you're just using scrap paper, no problem. If you're even doing this mentally, even better. Perfect. So let's jump to our follow along worksheet. I hope you guys are starting to see here that we can easily solve a handful of proportions, and that's what I said earlier today. It's our first group of proportions by reducing fractions and looking at equivalent fractions. And so that's what we're going to do here. Okay, so if you guys can pull up that follow along worksheet, go ahead and do that. I'm just gonna pull it up here. You don't have to pull it up if you don't want to. You can just look at my board here. So we have rows of 3. So let me scroll down a bit here. And we're looking for the unknowns in these cases. So let me just scroll this down a bit more, make sure you guys can see that. Beautiful. So the first question here is 11/12 is equal to something, some numerator over a denominator of 48. So how can we find that? You might ask yourself, can I first reduce the fraction that is known to me, where I have both the numerator and the denominator? That looks pretty reduced to me, so I'm not going to touch that. Or you might start by asking yourself, the two knowns that I can see there, the two denominators, do I know the relationship that exists? And hopefully you're saying, yes, absolutely. I know my 12 multiplication facts, and I know that 12 multiplied by 4 gives me that 48. And we're not going to do this for every problem, but I can absolutely show this with the first few. I know, and I know that many of you do know, that 12 multiplied by 4 gives me that 48. So what I do to the bottom, I must do to the top. So I'm going to take, and you can't see that, but all I'm showing is 11 multiplied by 4 gives me what f is going to be equal to, which is, of course, 44. All right. Let me give you all a few seconds to try out 2 and 3 as well. If you can find H and Z or Z for me while I just refresh my screen. So I'll erase number 1 here. Go ahead and please share with me what you find for number 2 and number 3. And think. Two thoughts in your mind. One is, what is the relationship between the two knowns, whether it's the two numerators or the two denominators? And 2, should I reduce the known fraction first? Will that help me out more than keeping the question the way that it is? So 2 thoughts that should be jumping into your mind before you look at the proportion and decide this is doable or not. All of them are doable. Let's just say that. To see, I'm seeing number 2, you guys are telling me is 72, and it of course is 72. So I'm just going to write that down here for anyone that's only watching and not able to hear me. And I'm seeing 21 for the third one, which is absolutely true. How did we get that? So I'm just going to maybe explain it rather than write it down. I'm looking at h over 16. So h is in my numerator, 16 is in my denominator. Cool. Then my second fraction is 9 halves, right? There's a 9 in the numerator and a 2 in the denominator. My two knowns are my denominators. What is the relationship between 16 and 2? And I might visualize this here. I could think backwards, but I don't want to confuse anyone that's new to this. To get from 16 to 2, the relationship is that I am dividing by 8. I hope you can read that there. And so now in my mind, I'm thinking, great, so there's some number h, where when I divide it by 8, gives me 9. So if you're comfortable thinking about that unknown, you can do it. You could also think the opposite way, right? We know that the opposite operation for division is multiplication. So I could also think that 2 multiplied by 8 gives me 16, and so 9 multiplied by 8 will give me h. Whichever way you do it, your answer will be 72. And maybe similarly for number 3, you have 24/56, and you're looking for the denominator in the second fraction. So you could try to observe, explore that relationship between 24 and 9. I did it for a few seconds, and I didn't see anything that was too obvious for me. So what I might choose to do is see if I can reduce 24/56. And lucky for us, we can. We can definitely divide those two numbers by 2. So if I do that, I get 12. And I get 28. And you can keep on going, or you could have originally, right? If I keep on going here, I divide by 2, I'll get 6, and I'll get 14. And then I'll get 3/7. Or you could have gone, and if you've mastered your ability to reduce fractions, you can completely divide by the greatest common factor and jump from this fraction to the 3/7. Regardless, once you get to that, you're left with 3/7 is equal to 9 over z or z. And now it's so much more obvious the relationship between the two knowns. 3 multiplied by 3 gives me 9, which would mean that 7 multiplied by 3 is what I'm looking for, which is 21. Beautiful. Let's jump to the next few problems. And we'll go a bit faster with these ones, unless a new skill or new technique comes up. I'm going to just scroll down here. While I leave these on the screen, I will refresh the comments. I love to see you guys participate, so I will do that for myself. Go ahead and try out 4, 5, and 6, since they're on the screen there. Again, if you're confused or you don't know where to start, ask yourself those 2 vital questions, whichever order works best for you. Maybe you want to see if you can simplify the problem first and foremost. So ask yourself, can I take the fraction that's given to me and reduce it right away? Or you might ask yourself first, what is that relationship between the two knowns? Okay. Oh, wow. Look at 4, 5, and 6 already answered for me. Beautiful. Thank you, Margie. Okay, so if I jump to number 4, and I'm just going to confirm that all those are correct, 11, 10, and 30, that's right. I have mine that I worked out as well earlier, so I'm going to write that down. Thank you. So it was 11. I can confirm that that's correct, and I'll go through them in just a second. Number 5 is in fact 10, and we were looking for R. And number 6, which is A, if you want to check that out on your own with your own work. A was in fact 30, yes. Let's confirm that, and I'm going to try not to use my marker here. I'm going to try just to do this mentally and speak or just explain my thinking in my head. M sixths, right? Some numerator over some denominator of 6 is equal to 55/30ths. I know I can reduce 55/30ths. I know that 55 and 30 both divide by 5, so I might choose to go there. But then I just ask myself that second question first, and I look at the 2 knowns, which are the 2 denominators, 6 and 30, and I actually know the relationship between those 2. I know that 6 multiplied by 5 gives me 30, or, thinking the opposite way, 30 divided by 5 is 6, which means that M will be either 55 divided by 5, which is 11, or some number multiplied by 5 is 55, which is also 11. Has to be, if we're thinking the right way, which we are. Number 5, let's confirm that it is in fact 10, so I'm just going to double check our work here. 25/20ths, my mind right away tells me I can reduce that fraction. Both of those 2 values are divisible by 5, so I'll get 5/4. That is helpful to me because 4 and 8 have a more apparent relationship to me than 20 and 8 do. And that specifically is that 4 doubled is 8, which means that 5 doubled will be r, which is why we have 10. Hopefully you're following along with my explanation here. Maybe I'll use my marker for the next 3 questions. Let's just go through 8 twelfths is equal to 20 over some value a. Again, 8 twelfths, right away my mind tells me, ooh, both of those are even numbers, so I could definitely divide by 2. Would that help me out? Yeah, I'd say so. If I have a 4 in my numerator, there is a beautiful relationship between 4 and 20. 4 multiplied by 5 is 20. So whatever I got in my denominator in reducing, which was 6, I can multiply by 5 and get my a, which is why we got 30. 6 times 5. Okay. Notice I did that all mentally. I didn't write anything down, but that's fine if you didn't maybe follow along there. Let's use our whiteboard for the next 3 questions. 7, 8, and 9, go ahead if you want to share those answers right away. While you guys try those out, I will again refresh my comments here. So try out 7, 8, and 9 for me, please. And I'm hoping that by now, just from the few questions we've already done together, you're not, as opposed to maybe how you viewed proportions at the beginning of this lesson, you're not viewing these as completely different questions. And what I mean by that is, whether you're looking for the numerator, the unknown in the numerator, or an unknown in the denominator, and on top of that, whether it's an unknown in the first fraction or the second fraction, you're not really changing up your technique too much. Maybe the slightest bit in your multiplication or division, or maybe you might change it up in the operations you use, but other than that, you're asking yourselves the same 2 questions, really. Should I reduce, or what is that relationship between the 2 unknowns? So let's see number 7 here. Okay, let's see here for number 7. Well, what do we get? This one's pretty easy to see. 2 multiplied by 5 gives me my numerator, which I also know is 10. So 9 multiplied by that same value should be my k, which is why we get the 45. I didn't necessarily have to show too much on my screen here, but I can if needed. I multiplied by 5 here, and so what I do to the top, I must do to the bottom, again, because we're working with 2 equivalent fractions. Okay. Number 8. What do we have here? Looks like I don't know the relationship between 12 and 18 so quickly. I could try to find it out, but I want to just, as a mathematician, what's the fastest way I could get to my answer? And so I believe for myself, and you guys might think differently, that reducing my second fraction will be the easiest. And so if I reduce 18/24, could I find the relationship between the 2 numerators? Well, let's see. If I divide 18 and 24 by 6, that leaves me with a numerator of 3. And 12 and 3 have a beautiful relationship together because 12 divided by 4 gives me that new numerator of 3. For those of you that maybe didn't follow along with that reasoning there, I will show you it right over here. Instead of the 18/24, what I'm going to write down here is 3 over 4. Because I reduced 18/24, I divided both the numerator and the denominator by 6. And the reason I did that is because it leaves me with a very clear relationship between my 2 known numerators. Right? If I divide by 4 going from left to right, or from right to left if I multiply by 4. Okay? Regardless, that leaves me with a j value of, so I'm looking at 3 multiplied by 4 is 12, so 4 multiplied by that same amount is j, which is 16. And what do we get for number 9? We should get 12. And why is that? I could very easily see that the relationship between the 2 numerators is that 21 is triple the amount of 7. And so I'm thinking c multiplied by 3 gives me 36. Knowing my 12 times tables, I know that that is 12. Okay. Just looking at the time here, maybe I will just really quickly go through the last 3 proportions, and then we'll jump to word problems just to address some of those. Whatever we don't finish today, we can look at tomorrow as our review. But 10, 11, and 12 here, I can share the answers after I refresh my screen. Let's see if anyone can get those for me before I see them, before I write them down, I should say. Okay. Again, do I have to reduce, or should I reduce? Will it help me out? Or can I leave it the way it is and just very clearly see the relationship? Okay. So let's see for number 10 here. I'm not sure I'm seeing it just yet. At least when I refreshed it. 10, hopefully you did get 25. Okay. 40 and 8 have a relationship in that 40 divided by 5 is 8. And so I'm thinking something divided by 5 is 5, and that something is 25. Number 11, W, you hopefully got 32 if you tried this out right now. 99 and 44 have a beautiful relationship. You can, that's not what I'm going for. 99 and 44 do not have a beautiful relationship. You can reduce, yeah, and get W is equal to 32. Or, let's try number 12 here. Y over 45, Y 45, if that's the way to say it, and 12 over 27, 12 27ths, 20 over there. Okay. So maybe I'll I'll use these as the review questions tomorrow if you guys want to try that out. And let's jump to a few word problems before we end for the day, or for this lesson, I should say. So hopefully you can see number 13 there on my screen, on your screen as well. Number 13, let's similar to that example I gave you earlier about the recipe and the pies, let's create our proportion and solve it from there as well. Okay. I took word problems where we will be able to solve the proportions using equivalent fractions, but as I said earlier in the lesson today, and for those of you that maybe didn't get to hear me, tomorrow when we explore part 2 of solving proportions, we'll look at a different technique in solving a different set of proportions where equivalent fractions and reducing fractions just don't really help us out. The relationship is too difficult to find, so there's a different technique we can use. Okay. So let's check out number 13 here, and at the very least do two word problems together. Then you guys can practice the rest and we can complete them tomorrow. If 2 bushels of apples make 17 liters of cider, okay, so again, I have some recipe. Exactly how many liters of cider can be made out of 42 bushels of apples? So similar to the proportion that we built from that pie recipe, we can build a proportion here. Be very consistent with where you place your units. So what I mean by that is if I'm going to form my first fraction, my first ratio, my first relationship with bushels in my numerator, so 2 bushels, I maintain that for my second fraction, my second ratio, and I'll do that in just a second. So 2 bushels make 17 liters. And I want that same relationship to hold when I'm looking at using up 42 bushels. So I'm not going to place 42 bushels in the numerator of the next fraction. I'm going to stick with the numerator, just like that first fraction. Okay? And so my unknown, as the question asks of us, is the number of liters of cider that can be made. If I reread that second part of the question, exactly how many liters of cider can be made? They're asking us to find that. That is my unknown. So I can first put a question mark, but once I understand exactly what that unknown is, I can have a variable. Again, mathematician's favorite one is x, So I'm just using that. X liters is what I'm looking for here. Once I've displayed all of that English in that word problem into some mathematical language, some relationship, I can summarize that even further for myself, remove the units just for the purpose of really thinking mathematically right now. This kind of simplifies it for me without all this extra wording in there. So now I'm left with something that we've practiced a lot with today, which is a very, I don't want to call it a very basic proportion. Some of you might not see it that way, but it is a proportion where I'm being asked to solve for an unknown. In this case, that unknown is in the denominator of my second fraction. So I'm asking myself the same two questions. Can I reduce a fraction? 2 and 17 seem like they're, 2/17 seems like it's a pretty reduced fraction. I can't go any further. And then the other question is, what's that relationship between the two knowns? And in this case, it is the two numerators. Okay, so I'm asking myself, what is that relationship between 2 and 42? So it looks like 2 multiplied by some number gives me 42. So if I could squeeze that in here, it's 21. So what I do to the top, I must do to the bottom. And so if you multiply 17 by 21, what you should get is 357. And that's how many liters 42 bushels of apples will make for you. That's how many liters of cider. Hopefully you followed along there. All I did was I took that wording from the word problem, created a mathematical statement from there. As you remember, the definition, or one definition of the proportion, is that it is the statement of two ratios that are equal, which is what I did here. With the one rule that I need to maintain, I have to be consistent with where those units are placed. Once I do that, I can remove some of that wording just to focus on the math that I have to perform. Great, did that. Then I used my skills from today's lesson. I solved for that proportion using equivalent fractions, and that's how I got to my answer. Let's do one more and we'll leave it for today. You guys can practice the rest of those word problems on your own. Bring those with you tomorrow and we'll review them as the first part of our lesson. So I'm gonna maybe scroll down first and then erase my screen. Give you guys a few seconds to try that out while, again, I refresh my comments here. I would love to see what you guys are saying. And I'll erase this in the meantime. Great, I'm seeing a lot of 357s for that previous word problem. Beautiful. Great. Wonderful. I'm loving you guys participating. Thank you. I apologize that my comments are not refreshing nicely for me today. Subi, you made a very interesting comment. So while you guys are trying out number 14, let me just address that. You made a very interesting comment. You said just figure out how much 1 makes and solve it for the rest. Yes, you could do that. You could figure out either how many liters 1 bushel makes, or the other way around. It depends on how very comfortable you are with your math. And that would get you to the right answer. You run the risk of running into decimals, and in this case it might be pretty decimals. I didn't try it out, but it might be. But why? Try to stick with, and if you're a Mathnasium student, you'll know this, but maybe not even Mathnasium, just mathematicians altogether, love to stick with fractions rather than resorting to decimals, right? It could get pretty ugly with decimals when you start to round and whatnot. So A, try to stick with fractions, and B, that just sounds like a lot more work to me, to be honest, and a true mathematician minimizes the amount of work they have to do. Okay? So I'm going to write down number 14 here, and let's see how to approach this. It asks us that if we have a scale drawing, and in that scale drawing, 6 inches represents 24 miles. If you don't know what a scale drawing is, let's say I have a little map here of some area in the United States or some other country. 6 inches on my map is in reality 24 miles in the real world. Okay, so this is just a scale drawing of that. So given that that relationship holds, let me just even write that down while I have that fresh in my mind. This is the relationship between my scale drawing and the real world. I've just decided inches will be in my numerator, miles in my denominator. If I wanted to flip that around, that's fine, as long as in the second fraction I maintain that. Okay, that's going to be equal to something, and that something will have the piece of information that's being asked of me. So exactly how many miles does 10 inches represent? Okay, so they're asking me for 10 inches. And how many miles? So normally I would have a question mark here, but I can be specific and maybe even have a capital M here for miles. Okay. And now if I am not comfortable, I'm still not seeing the math that I have to do here, I can remove the wording now that I've correctly taken that word problem, those sentences, those questions, and written it down in a statement. I can remove some of that extra wording here and see that I have, oh, not 6/4, 6/24 is equal to 10 over some m. And now, hopefully it's very clear what math we have to perform to find that unknown. Hopefully it's very clear that we're solving for a proportion. That's the first thing. The second thing is I have two knowns, my two numerators, but to me, it's not right away clear, that relationship. Okay? So what I might choose to do is reduce this first because I know my facts very well, and I know that 24 is divisible by 6. It's divisible, 6 divides into 24 4 equal times. So I could simplify this. Does that help me out? Well, let's see. 6/24, I can, what did I say, divide both by 6, so I get 1 over 4, 1/4. Yeah, that's helpful. Actually, that's super helpful because 1, of course, multiplied by 10 gives me 10. So 4 multiplied by something, 4 multiplied by 10 gives me that something that I'm looking for, and that, of course, is 40. So M here is 40. 40 what? 40 miles. Okay. I'm going to end it there, just for the sake of time. I welcome you all to try out the rest of the word problems on that page. And then the third page in that document is just extra proportion problems you can practice solving. If you'd like the solutions to those, reach out to your nearest Mathnasium. We have many instructors that would be more than willing to help you out and have these conversations with you, these discussions on solving proportions. Maybe we'll find that you would benefit from some practice on some prerequisite knowledge, or you'd benefit from some more challenging applications. Regardless, I hope to see you tomorrow. We will complete the rest of these word problems and move on to a second technique we can use in solving proportions. Have a wonderful day. I'm not sure what weather you have where you are. I have a very rainy day. I don't know if you heard the thunderstorms earlier. So I'm going to go enjoy that and complete some of the rest of these math problems for myself in preparation for tomorrow. I hope to see you all there. I hope my comments are working a lot better tomorrow. Have a wonderful day, and we'll see you tomorrow. Bye-bye.
It's afternoons that seem to be the most hectic for us, so it was much more convenient when we found Mathnasium at home.
All right, so how do we do half of 5? I think one of the best things about at home is that it really feels like you're almost at home with the student in their house teaching them.
I'm in my comfort zone.
You can just ask for help and the instructor will come right to you.
With Mathnasium at home, I know that they're getting the help that they need.
Awesome, great job.
Mathnasium, changing lives through math.